Okay, I think we are ready to start. Welcome everyone again. Very happy to welcome you to our webinar for autonomous measurements with CALIPRI measurement systems. So what's the plan for today? I would like to give you a quick brief overview on our CB20 systems and all the add-ons to that. If you have any questions, please feel free to post them in the question section of the GoToWebinar. So we're planning to have approximately 30 to 40 minutes of input from our side. So tell you a bit about our portfolio and especially about the CB20 applications. And afterwards, we would welcome you to have a little discussion with us, post your questions, and we would like to answer them as far as possible. So let's get started. Yeah, we're speaking, of course, about gap and flash measurements in the automotive industry. So why exactly are we talking about that? So what's the customer pain? What's your pain as an OEM? What's the pain as an end customer with gap and flash? So if the flash values, for example, are out of spec, we will create more wind noise in the car. This is especially important while our drivetrain switch over to or from internal combustion engines to battery electric vehicles. So noise in the car is a big issue for car manufacturers these days. Also, it will reduce our aerodynamics. So especially for premium OEM sport car manufacturers, this plays an important role. And it also comes back to the issue of wind noise. So basically, a car is built like a fish. The the part that is further to the end is always a bit underflashed, so the wind can pass by. If that's not like that, so if parts are sticking out, we've got an increased risk of injury in an accident because parts are sticking out. We reduce the aerodynamics. Again, parts are sticking out. We will create wind troubles, which will create more wind noise. And also, we've got a risk of corrosion there. So because there could be potential water intrusion when parts are sticking out, humidity will stay there and we have corrosion risk. So we want to avoid out of spec flash values at any cost, of course. If gap values are out of spec, what does that do to the car? So number one, we reduce the tightness. Again, we're speaking about noises on the car. We want to seal the car, the inside of the car, as best as possible from outside factors. So the gaps have to be relatively close, while still not crushing into the next part. Also, it will influence our sound when closing the doors and trunks, but most importantly, it will decrease the perceived quality and optics of our cars. Perceived quality of the optics is a very important part. So when a designer comes up with a car, well, he creates a clay model and he doesn't think about the doors and the functionalities about it, but he thinks more about the optic of a car. So the gaps are especially important because they need to be just right, they need to be parallel, they need to have the same values along one and the same gap, so the car just looks right. Especially with our modern designs, if the gap values are out of spec, we will have a perceived quality, so a quality from a customer perspective, which is just not up to the spec that we're trying to create. So we now talked about the customer side. What about the OEM side? So why are we checking for gap and flash, and what are we trying to reach with our gap and flash checks? Of course, we want to decrease costs. So we've got our nominal values that we want to reach, and we don't want to rework our vehicles. So what's our goal? We want to shrink rejection rates and vehicles in rework. We want to get things right the first time we do it. We want to lower personal costs. So we don't want to run around the car with feeler gauges and measurement plugs. Well, this is a very big work for us, the very big work scope. So we want to shorten cycle times and reduce human errors. Of course, we want to improve the quality and efficiency of our processes. So we want to enhance vehicle and production quality. Again, speaking about getting things right the first time. communication is a very important factor. There are different production steps in all OEMs, from body in white to paint job to final assembly, and we need to communicate between all the production steps to have an excellent product in the end. Also, we want to detect the wear of tools in previous measurement processes and yeah, basically switch out tools before it's too late, before they influence our production quality. And we want to have a maintenance-free operation. Last but not least, of course, we want to avoid line stoppages. So if we're talking about mass production of vehicles, we need to avoid crashes. We need to avoid line stoppages at every cost, because there's so much dependent on the line running. There are techs before us, techs after us that we don't want to disturb. So what we do for that, we offer turnkey solutions for high customer values, and we want to avoid errors in line, because that's just as important as high quality measurements. So again, what are we going to speak about today? First of all, I would like to give you a quick introduction into CALIPRI measurement technology. So what is CALIPRI? How does it work? How does it show me what I expected to show? Then I would like to switch over to a very brief overview on our automotive portfolio. And then we finally come to the part which we're waiting for today, the automated applications, the CALIPRI CB20 solutions, the CALIPRI CB20 range with the repost add-on, and finally come to a conclusion. Afterwards, again, I would like to welcome you to a quick questions and answers round, so we can have a bit of discussion on our solution. So, starting off, what is CALIPRI? CALIPRI is a 2D profile measurement system for body flush and gap applications and fold edges. So, most of you will know hexagon from other applications, mostly 3D scans. So we are not in an absolute world, we do relative measurements. Again, CALIPRI is 2D profile measurement systems. So we take a cut out of a profile, display this profile, evaluate it for you, and give you values, repeatable, user-independent values out of it. CALIPRI captures profile curves with a laser and a camera. I come to that in the next slide and explain it a bit more how that works. CALIPRI evaluates and captures data, provides dimensions. It's a patented laser light section technology which gives highly accurate, reliable, and user-independent results. So how does CALIPRI work? CALIPRI, in comparison to traditional laser triangulation, does not work with one laser line, but with 3 laser lines. So there is a measurement line in the middle and a reference line above and below. With that patented laser light section technology, we avoid roll, pitch, and extrapolation errors. So how do we do that? There's a measurement line in the middle, a reference line above, and a reference line below. Depending on the position of the sensor relative to the measurement objects, the reference line will have a certain distance and a certain position to our measurement line. So if you roll the device, those lines will spread. If you tilt the device, those lines will form a certain V shape. Our system can recognize the tilt and roll angle, and the patented CALIPRI principle, the patented algorithm, will correct the tilt and roll movement, enabling us to rotate our sensor around a profile and capturing a profile from each and every angle. So it's an easy workflow for the operator, for the handheld gauges, which we are not going to discuss more in detail today. But it's also a very huge benefit for our autonomous platforms, because the laser doesn't have to be positioned perfectly perpendicular and in a 90-degree angle to the profile. And hence, we are a bit more free in the robot programming. And also we are a bit more flexible if a car isn't sit right on a skid or doesn't sit 100% on a conveyor belt. We're free to move our sensor around in the space. The algorithm can correct it and will help us with the 3 main errors of laser triangulation. So what are the three main errors of laser triangulation? Basically, there is a roll error, a pitch error, and an extrapolation error. A roll error will exist if you're not measuring 90 degrees to our profile. So in our case, again, we have the CALIPRI technology. If we wouldn't be in a 90-degree angle, our lines would form a certain V shape. We correct that already. Pitch error. If our sensor, or if a sensor of a traditional laser light section sensor isn't perfectly perpendicular to the surface, we would create a pitch error. In our case, our reference line would spread from our measurement line. We can correct that. No worries about that. And also, and that's the most important error, extrapolation errors. So what are we talking about when we're talking about extrapolation errors? I'll give you a little bit more overview in the next more sheets. Just to give you a quick insight, with our technology, we can either rotate our sensors around the gap with the handheld sensors as well as with the autonomous sensors, and so have a very deep scan of our profile. So we check our profiles from each and every angle. We scan into the profile very deep, enabling us to not use extrapolation. What different edge types, what different gaps can be evaluated with CALIPRI? Yeah, basically everything. So starting from body in white, where we have a lot of steel gaps, sharp gaps, very special gaps, we can evaluate it. But also in final assembly, we do have solutions for very special gaps, such as T gaps, which will be created on the trunklet to the bumper, or H gaps, which we often see on the hood to the front light. We are very flexible in the evaluation because we have a very deep scan. So, for example, taking that gap here. More data, again, means more flexibility for evaluation. As we scan the gap from each and every angle, we don't have to extrapolate, so we don't have to create radii or something. We check the real profile and work on the real profile. With the help of some parameters, we can now adjust our evaluation strategy, our measurement strategy, depending on either what's in your gap and flush catalog or what you would like the measurement to look like. You set the parameters once in the measurement plan and can then follow this strategy throughout your whole process, really beginning from research and development up to the finished car. You apply the same strategy. You have toolings which will create always the same measurement, or which will give you the ability to do a very deep scan, and hence you can always apply the same strategy, having comparable values throughout the whole process. Again, speaking about data versus extrapolation. So what am I speaking about with extrapolation? Traditional sensors, especially with inline measurements, with autonomous robotic measurements, will create what we call incomplete scan. Basically, what they see, they're being positioned perpendicular to the surface in a 90-degree angle as far as possible. And what they will then do is a single shot measurement. So what they will now see is radius beginning on the right-hand side, radius beginning on the left-hand side. This is a bit of a problem in the automotive production because our radii are never perfect. Basically, there are a lot of influences on the radius with production. Hemming processes, painting processes, coating processes, tool processes, everything. So normally our radius would start out with a small radius, having a more consistent, bigger radius in the middle, and then a small radius in the end. Depending on how much of the radius would be captured, extrapolation values would be different. So why do we extrapolate? Of course, with that scan here, so we see the deep blue scans. This is what the traditional system would actually capture. They capture just the radius beginning. If they now want to see the tightest distance in between those 2 points, they need to extrapolate it because the radius will go further. What does extrapolation mean? We take our radius and we basically fit a ball or radius in there and enlarge the radius so we have 2 points facing each other at a very small distance. Depending on which radius you capture, and again, here we go back to what I've said before, the radius isn't consistent. Depending on how much of the radius I capture, those values will differ. And those values will give us an inconsistency, which will be displayed in not repeatable measurements. Not with CALIPRI though. With CALIPRI, we are able to scan the whole profile and have consistent values over all cars, over all measurements, over all operators, over all platforms, if we're speaking about autonomous measurements. So what does our portfolio look like? So I gave you a quick overview. As I already said, we want to concentrate on the CB20 solutions today. Just to give you a bit more insight on what we're actually offering, we are offering different solutions, starting with the CALIPRI C14, which is an handheld, offline, portable solutions, ergonomic design for continuous work in offline applications. So it's suitable for shop floor and lab operations, but it's very flexible as it's a tablet connected to a sensor. We are very flexible, can go around everywhere we want to. Also, we do offer a CALIPRI C15, which is the big brother of the CALIPRI C14, basically. The CALIPRI C15 is used in handheld, inline, and nearline operations. It's not as flexible because it's integrated with the PLC or barcode reader, but it will give you some more advantages, which is automatic program loading and efficient and very fast manual measurements. So basically, you can use 2 sensors for one car, and the backend is a bit more performance oriented. And of course, we do offer the CB20 range for automated solutions in body and white, in paint shop, and in final assembly. We can reliably measure translucent surfaces, we can work with that on industrial and collaborative robots, and also as an add-on, we do offer the vehicle position detection VPOS, which will detect the vehicle position and orientation of the vehicle while the vehicle is moving or also while the vehicle is stopped. So where are our gauges used? Again, we can say basically everywhere, really starting from research and development, climate chamber test, designs, and so on, to the stamping facilities where we can check tooling, where we can check hems, and so on, to now body and white, where CB20 solutions, by the way, CB20 solutions is what we formerly called C12. So if any of you guys are familiar with C12, the CB20 is now the C12 is now renamed C12 is now renamed CB20, just to avoid any confusion here. So the CB20 is used in body and white applications. Basically, cars on a skid. Car will be in our measurement station, and then cars transported out of this. We can also use CALIPRI C14 and C15 solutions in the body and white, in the paint shop again, and in final assembly. Everywhere we can use our applications, handheld as well as automated solutions. And this is very unique on the market. So it's a great benefit for you as an OEM to use CALIPRI because it's correlation free. We use the same measurement strategies and the same measurement plans over all of our platform. The technology in the handheld gauges as well as in the robotic sensors is the same. We always use CALIPRI technologies. It's the same sensors. It's a bit different, but I come to that later for the autonomous solutions. But it's the same sensor units, same technology, same measurement plans. So you will have a correlation-free measurements in between the start of the process up to the finished car. So finally, we come to our automated applications. CALIPRI C12, okay, we just talked about it, will now be CALIPRI CB20, CALIPRI CB20 CB, which is the final assembly sensor, and VPOS as an add-on for vehicle detection. So how do our applications look like? So basically, there are different setups for the robotic cells. Mainly, we do have robots, of course, because, well, the sensors are robot guided. Then there are our sensors mounted to the flange of the robot, and there is a machine interface at the side of our station. CALIPRI CB20 solutions are and can be sold as 1, 2, or 4 robot systems. Depending on your tech time, depending on the application, if it's body in white or if it's final assembly, and depending on how many measurement points you want to measure, we can choose the correct system together so that you will cover all of your measurements, all of your measurement points. Also, an upgrade to a 6 robot system is possible. It's not that usual, but a 6 robot system is possible as well. We are platform and manufacturer independent. So you can use our sensors with industrial robots, but also with cobots, with collaborative robots. So both sensors, the CB20, which is, well, the body in white and paint sensor, and the CB20CB for final assembly with transparent surfaces, are sub 4.5 kilograms. So basically, most of the robots that are on the market can carry our sensors, so that's no problem. Of course, the robots can also be on a 7th axis to enlarge reach. So especially if we're talking about final assembly and the car is moving, then we can also use a 7th axis for the robots to get a bit more reach on our robots. In some cases, we could potentially also use linear actuators to put our sensors into position. Again, this is not too common, but could be done. So what do our automated applications look like? What makes them so special, especially compared to our handheld gauges? On the top here, we can see our 2 sensors, the CaliBreeze CB20 and the CaliBreeze CB20 with the CaliBreeze unit below. Both of them feature a twin head technology. So we have seen our manual gauges that are just rotated around the gap. In our automated applications, one of the main things we're trying to reach is a very short takt time. So we're trying to reach a very fast measurement times. Hence, we have decided to create a twin head sensor. The sensors, the 2 light section sensors, are within a 60-degree angle. So you might want to ask why it's not a 90-degree angle, because that's fairly common on the market for twin head sensors. We decided to put them in a 60-degree angle because we can still rotate them around difficult gaps. So this means especially on trunklets or headlights where we spoke about that earlier, where we have the T gaps or overhanging H gaps, we can still rotate our sensors around to capture more of the radius that would be difficult to capture in a 90-degree angle. So our sensor is still rotatable, but it does not have to be rotated in all cases. So the 60-degree angle and the twin head technology will enable a so-called one-shot mode. So we reduce the measurement time because we just position the sensor in front of the profile. The profile will be captured, it will be very fast, and then we can move to the next point. Right-hand side of the sensor captures the left-hand side of the profile, left-hand side sensors captures the right-hand side of the profile. We combine that measurement and can then do the evaluation just like we would do with a C14 or C15 with the handheld gauges. We have a very deep scan because we scan from both sides. We can still rotate if it's required. We don't have to. Quick measurement time, but still rotation possible. So where is the CaliBreeze CB20 range used? It is used basically starting with body in white. So we do have the possibility to measure a car on a skid. Usually the car will be in a stop position, so the skid will be transported in our measurement cell, skid will be lifted, then we do our measurements, and car is transported out of the cell. It can also be implemented after paint or after coating, and of course in final assembly. When we're talking about final assembly, we can measure on the moving conveyor belt, and we can also measure at offline cells. I'm gonna talk about that a bit later. I think we are very clear on what we can do in body in white. So in body in white, autonomous applications exist since many years. So again, the measurement is fairly easy. The car is on a skid. It's repeatably in one position. So we don't have to worry about the car position too much because the skid is very repetitive. It can be lifted, and the measurements, again, you know about CALIPRI technology, deep scan, always the same evaluation technology, no extrapolation required. So we will give you an extremely accurate and repeatable scan there. Again, fairly straightforward. If we're now talking about final assembly, we do have some challenges, of course, that don't exist in body in white. Challenge number one, transparent surfaces. So transparent surfaces, of course, are always challenging. We are talking about optical measurements. An optical measurement requires a reflection of some kind, otherwise our camera wouldn't see anything. So basic setup, we have a camera with a wavelength filter of the wavelengths of our laser. The laser is shot on a surface and the camera captures the laser on the surface. If we now have a transparent surfaces, there are reflections on the edge. There can be penetration of the laser into the surface, and if the laser penetrates the surface, it can be broken off to different wavelengths, and we can't really see anything anymore. So reliable results cannot be guaranteed with optical measurement solutions and laser triangulations. So again, we're not sure if we're even, we are not sure if the laser penetrates the surface. Sometimes we don't even see anything. There can be poor reflectability. Edges can have difficult contours. There can be reflectable parts beneath the translucent plastic, which will influence the measurement result as well. So we will have inconsistent results. What's the solution to that now? Conventional gauges. We always used to have red lasers. Now most of them are blue or ultraviolet lasers. Why are they blue or ultraviolet? That's something we can see in our picture here. The closer or the shorter the wavelengths of a laser is, the less penetration you will have on transparent surfaces. So here we see it for macrolon, which is basically a transparent plastic. And here we see that at 400 nanometers, the transmission breaks off and we will get a reflection. However, this is not true for all parts. So especially for glass, it might be even shorter. So what's the solution to that? Again, we see on the market there are blue lasers, ultraviolet lasers, lasers that are in between, and they all claim that it's possible with them to basically see on transparent surfaces. We have tested everything, and we are not sure whether we do get some transmission with ultraviolet lasers. Also, we cannot apply our CALIPRI technology to all of them, so we decided to go a completely different way. And that's what we've done with the CaliBreeze technology. CaliBreeze technology briefs an ultra-thin layer on the translucent surface to make it non-translucent. So basically, the guys who are wearing glasses know exactly what I'm talking about. It's a cold winter day. You go inside and suddenly your glasses fog up. This is the same, or this is the physical phenomenon that we use to make transparent surfaces in transparent. So we have a little nozzle on our sensor, which briefs a thin layer of condensation on our transparent parts, makes them intransparent for a while, while not leaving any residues. So now we are able to capture each and every surface on the exterior of a vehicle. So it doesn't matter if it's glass, if it's transparent plastics of some kind, if it's compounds with a clear coat. With CaliBreeze technology, now everything can be captured because we make every surface intransparent for a second without leaving any residues. Different color contrasts can now be inspected. So if we have a very harsh contrast between, let's say, very shiny white and a flat black, this can also be inspected. And also, we still use a class 2M laser, which means no safety concerns. So this is very important as well, as the UV lasers, they can damage the eye. So we have to make different security concerns with UV lasers that we don't have with our class 2M lasers. Also, the class 2M lasers, they don't use as much power as a UV laser. So the system, doesn't create as much heat and doesn't use as much power. And also, and this is very important, we capture the most outermost layer every time. So we make sure that we don't penetrate the surface, but we always measure on the most outermost layer, again, guaranteeing repeatable results. So how does that look in action? So here a little insight of our production facilities. You can see the nozzle breathing on the transparent surface. We create a fog layer, a condensation layer, which will disappear. So there will be no residues as we are using distilled water. So we can always measure on the customer car. We make sure to be able to measure each and every surface. Sorry, to measure on the most outermost layer every time and to be repeatable. So we have a solution for problem number 1, the transparent surfaces on a finished vehicle. So now, speaking about final assembly, we do have another problem or another challenge, which is basically our car is not like in Body in White that it's stopped, but the car is moving on a conveyor belt. So how do we make sure that we can measure autonomous, but with a moving car on a conveyor belt? So let me show you a quick video. So now you've seen a quick visual representation of what the VPOS system looks like. Don't worry, it's not just a visual representation. It's approved, it's installed, and it's already running in a production facility. So what's our challenge? The vehicle position on the conveyor belt varies due to various factors. So with the positioning process is one factor of those. Cars can be manually driven on the conveyor belt. It can be loaded with cranes. They can be loaded on a skid. They can be loaded from an autonomous vehicle of some kind. So this will have an influence on the vehicle position on the belt itself. Also, the vehicle-to-vehicle variations exist. What does this mean? There are differences in wheel and tire combinations, tire pressures, springs, shock absorbers. Do I have an air ride? Are the springs already settled? What's the tire pressure? So this will all influence our vehicle position. Our vehicles can, of course, vary in X, Y, Z. So basically, okay, we have a different height of the car. The car can be shifted right to left. And of course, it's moving forward because we are on a conveyor belt. Traditional systems normally can capture that, but they don't capture rotation. And they also don't capture tilt angles. So what we now do with our vehicle positioning system, we make sure that we don't only capture X, Y, Z, but we also capture rotations and tilt angles. Alpha, beta, gamma. So basically tilting forward, tilting sidewards, and tilting diagonally. With our VPOS system, we can make sure that we detect all the positions in X, Y, Z, alpha, beta, gamma, and also moving forward. I'll give you a quick overview later on as well. So why do we do that? After all, basically on the moving conveyor belt, we have to make sure that the measurement position is correct due to two reasons. A, we want to avoid our sensors crashing into the car. So we have to make sure that they are far enough away from our car to not crash into the car. But also we need to have a very high availability of the system. What do I mean by availability of the system? The sensor has to be close enough to the car to capture measurements. So this is what the VPOS system makes sure. So coming back to our sensor, this is what the sensor looks like. The CB20 CB system, for example, we have an homogeneous twin head sensor, 2 camera with improved HDR features, and 2 class 2M lasers. So one is 405 nanometers, the other one is 450 nanometers. It's rugged design for robot designed for robot communication, so it's lightweight. In our case, the sensor is 4.1 or 4.4 kilograms, depending on the setup. So it can be used by by every robot type, industrial and collaborative. It's IP54 approved, so it can be used in all company and in all factory positions. So, and down here we have the CaliBreeze unit. So basically it's a nozzle and a heating spiral behind that. So there's what we then do is we push approximately 100 microliters of distilled water through a heating spiral, which will create a condensation, a kind of fog, which will condensate on the surface. Also, don't worry, in that case, for security reasons, the condensation, it's very low temperature. It's not like it's super hot or something. You can hold your hand in front of it without burning yourself. And there is no residue on the car, of course, because we measure on customer cars. So we want to make sure that there is no residues on the cars. Data sheet wise, I don't think we need to especially go for that. Just some important things that you might want to consider. Weight is one important thing. So 4,120 kilograms for the CB20 unit, which is the full spec CB20 CB unit. This means we can use collaborative robots as well as industrial robots. Measuring area, distance to object, needs to be plus minus 25 millimeters. This is very unique on the market because we can vary in the position a bit due to the tilt and roll correction. we can be further away or closer to our object without influencing our result. Accuracy and repeatability, plus minus 20 microns, plus minus 10 microns. This is benchmark on the market. So we are very accurate with our gauges. We are very proud to have that accuracy. And this is comparable to basically nothing on the market. So from our software usability, you will see that the software looks basically like the software we're using in our handheld gauges. So we have our points, have a visualization, and also do have a scan visualization here. Here you can see the system running on one of our company vehicles, and you can see how that works out. Something which you don't really see very often because, well, it's autonomously used, but this user interface will be very familiar to our CaliPreeze users anyway. So there we go, and then we've finished our whole call already. How do we calibrate our system? Fairly easy. We got a 3-stage calibration. There is a sensor self-test on the top part here. Then there is also a sensor verification. So the sensor calibrates itself after the calibration, or the sensor self-tests itself. After the self-test, it does a verification on the lower part here, which is a 1 millimeter gap. So we see, okay, how wide do we measure? And there is a CaliBreeze unit verification even below that, where we have a transparent surface and see whether we get some decent reflection or not. And also there is a VPOS verification, which is basically a TCP tip, which can be mounted on the sensor. And then there will be a cone added to the car, so we can make sure that we always have the right offset from the robot. Again, speaking about the CaliPreeze CB20 system components, I think we talked enough about the sensor components, CB20 components, how does that look like, VPOS components. So basically what we do have is a light barrier. The light barrier will trigger our 2 VPOS cameras above the line. Those 2 3D cameras will capture the position of the car in height and deviation, so Z and X. There is a secondary sensor to the VPOS, which is a rotary encoder, which will give us the speed of the line, also with latencies of the belt, because, well, the belt is basically very heavy. It's very full of cars, so we've got some latencies in the belt itself, which can be captured over a rotary sensor. And also the 3D cameras will now give us rotation and alpha, beta, gamma. So we can always make sure to position our sensors here correctly. The offset is of course done automatically by the whole system, and so we can now offer you a solution where we can reliably measure on the final assembly on a moving belt, can reliably measure all surfaces, and give you a complete solution for your final assembly. So again, CaliPreeze CB20, highly reliable flush and gap measurement, autonomous inline and offline operation, simple operation with each and every robot, 24/7 operation guaranteed. And the VPOS helps us to determine the position of the car in 6 dimensions, X, Y, Z, alpha, beta, gamma. It's for moving line and stop and go operations. It's also for offline operations. It will provide the position and position information, and will translate this position information to an offset to the robot, so we can make sure that the robot is always in the right position. High availability, no risk of crashes. What's the benefit for it? We're custom efficient. So it's a long-lasting standard sensors that are used, safe operation guaranteed, no harming lasers or fluids are needed. Our software strengths, of course, that we have with the other platforms as well. Complete profiles captured very quickly, flexible evaluation, analysis depending on your needs, whatever your gap and flush catalog look like, whatever your guidelines look like, we can help you with that. Autonomous performance with the CALIPRI principle. I think we talked about that already enough. Cross-platform use, which is very unique. Again, same measurement strategy, overall gauges in the line, overall production steps, so no correlation needed in that case. And of course, CaliBreeze technology. With that, we can reliably scan all surfaces. Doesn't matter if glass, if compounds, whatever. The post benefits. One of the big benefits that I want to emphasize here, that we do have a minimum space requirement. So we just need 1 meter, 1.5 meter before the actual station, and not a whole tag before the station to determine the vehicle position. Also, we have an extremely broad range, so we can capture big vehicles, small vehicles. It doesn't matter if it's a Smart or an F-250, both can be reliably and accurately captured. It's maintenance free, so once it's set and nobody touches it, you can use it basically forever. And it captures the complete vehicle, not just a couple of points, but it captures the complete vehicle, which will also allow us extreme offsets. So where is CALIPRI CB20 used? Basically, 90% of the time it's used in inline operations and integrated within the production. It can also be used combined with a rework fitting station, which I will tell a bit more about in the next slide. And it can also be used in an offline inspection to increase the throughput. So basically, you can create an offline cell for your audits and just park the car in there. vPost will capture the position of the car, and we will do the complete audit for you with our robotic inspection. So I just talked about combined rework and fitting stations. So what do we have to offer in that case? We can upgrade our CB20 solutions also with C15 stations or with more stations afterwards. Because we now have captured the car, what are we going to do with the data? Either we push them to the SPC and just leave it there as it is, or we rework our cars to make sure that we always deliver the perfect car to the customer. We can help you with a data forwarding station. So basically, if we capture the data in an autonomous station, we can forward that to a repair station. In the repair station, a worker could use CaliPRE parts. So basically, he sees, okay, on the data forwarding station, okay, I have to repair a part of that. If he then wants to make sure that the repair is successful, he can use CaliPRE parts, which basically selects just a part of the measurement plan, and he can then remeasure it to make sure that the car is in perfect condition and can go to the customer. So summing up, we have covered it all. We supply automated measurements, reduce the labor costs with high-speed measurements combined with the highest repeatability on the market, shorten circle tag times, reduce human errors, collaborations with various integrators in different regions. So we can help you basically everywhere around the globe. Handheld measurements, nothing we want to focus on today, but again, we have the same results on our handheld measurements as we do have them with our autonomous solutions. We can detect the vehicle position and orientation. So it doesn't matter if the car is stopped or if the car is moving on a belt, we can help you with the vehicle position. So we can make sure to measure autonomous in each and every production step, doesn't matter if stopped or moving. We help with the data handling, so automated data transfer, remote system diagnostics and support. We immediately create results and enable immediate actions, just like with a repair station. We supply the repair station for you, so with the same evaluation method, you can override after a repair, so you can make sure that the car is always in perfect condition if you deliver it to your customer. So for now, I just have to say Thank you for your attendance. Thank you for listening to me. If you have any further questions, please feel free to contact me, to contact the sales team. We will be more than happy to answer all your questions. We will be more than happy to visit you on site to show you some more benefits of our handheld systems and also the automated systems. Please feel free to give me a call, shoot me an email. Thank you very much, and hear you soon then.